many people haven't been able to wake up, but Lord Father, we thank you that you have protected us and made us wake up this early morning. We thank you, Lord, for our teacher. Thank you for his provision you had made to him and so to us, Lord. We pray that today we're going to hear, that we're going to study, Lord. We pray for that wisdom that you can be over us. Let us understand each and everything, Lord, and continue blessing our teacher, Lord, Father, during this course of our studies, Lord. We pray and believe in Jesus' name. Amen.
Amen. Thank you so much for the word of prayer. Good morning once again, and thank you so much for joining this session. Today, we are going to continue looking at geometry. Today, we are going to continue looking at geometry, and we are going to look at other mock bodies. That is what we are going to look at in our session today. Yesterday, we started with the first mock body, and today I want us at least to be able to do 2 mock bodies, and then I'll give you some exercise of the numbers that I would love you to try out. Yes, so that is what we are going to be doing in our session today. So, okay. Now, in our session today, we are going to start with JJEB, and we shall look at the first item of JJEB. When you look at JJEB, they told us that we have an extension worker mapped a village demonstration farm on the Cartesian coordinate in 3 dimensions. He installed a sprinkler at a point S inside a greenhouse. And they went on and they told us that the greenhouse roof is a plane. And I told that whenever you find the word a plane literally means a flat surface. So those who know a greenhouse, like the way you see your house at home, so that is how a greenhouse also looks like. The way you can imagine that you have a house and this is its roof, something like this. This is your house, and on this house you have a roof. That is a simple house. So they told us that inside this house they installed a sprinkler at a point this. But they went on and told that the greenhouse roof is a plane. Now you can look at a plane as a surface, but in 3 dimensions. A water pipe will run along the line. This is the line, enters the greenhouse roof at a point P. Now you have a greenhouse, and inside there is a pipe that passes through. Inside this pipe, let me say, but at this point where the pipe passes is point P. So the extension worker wishes to move the sprinkler closer if the distance between S and P is more than 5 meters. Now, the point P is inside the greenhouse. The point S is inside. Let me say this is the inside and this is the point S. And at the point P here you want to obtain what is the distance from this plane here, from the point P to where S is. So in simple terms, they are asking you to find the distance between S and P, and you verify whether it's more than 5 meters. Now, as you break down the scenario, you are going to ask yourself, this point P is where the pipe passes as it enters through the greenhouse. Do you know what point P is? So when you look at point P is meeting the plane or this plane, the flat surface of the greenhouse, meaning that the first thing you need to ask yourself is, what is that point P? What is the point P before I calculate? Because you have your point S, but you don't know what point P is. But when you look at point P, is along the plane, which this is our plane. However, that point P runs along the line. So you have the line here that is taking the water and it is meeting the plane. So in order for you to obtain this point P, you need to find the point of intersection of the plane. You need to find a point of intersection of you need to find that point of intersection of your plane. So now that is what we are going to be looking at, that where is that point where this plane meets with my line. So that is the first thing. So once you meet the line and a plane meeting, it means that you'll be good to find that point P. So we are going now to start. So now when you look at our scenario, they have given us our plane. Our plane here, they have given us as 3x minus y plus 2z. Allow me to remove this equal sign, equals to 7. That is the plane. Now what are you going to do? You are going to first obtain the distance between S and P. That is what the scenario wants you to do. So now obtaining the distance between S and P, you are identifying what you are going to do. So what are we going to do? We have our line, which is 2 plus mu I plus negative 1 plus 2 mu of j, then plus 1 minus the 2 mu k. Now this is the line. This is the pipeline that is passing through the roof. The roof is here. So you are going to ask yourself, where is the roof and this line, the pipe, meeting? Where is their meeting point? So in other words, you are finding the point of intersection of a plane and a line. So how are you going to obtain that particular point? So you know that our R is a Cartesian plane, which is in form of X, Y, and Z. So what does it mean? We can write this as X, Y, and Z. And this one will equal to, if I'm to write it in this form, it will be 2 mu negative 1 plus 2 mu, and then I'll have 1 minus my 2 mu. What does it mean? It means that your x is the same as 2 plus mu, your y is the same as negative 1 plus 2 mu, and then your z is the same as 1 minus the 2 mu. Now, after obtaining that, what are you going to do? After obtaining what your x is, what your y is, and what your z is, now you are going to go back to the plane that was given to you. So our plane was given as 3x minus y plus our 2z equals to 7. So where there is x, you substitute. Where there is y, you substitute. Where there is z, you go on and substitute. So we are going to substitute for our x, y, and z. But let me first pick on, yes, Sunachas. Sunachas. Okay. Let me hope members now you can see the question clearly. So now we are going to substitute and we shall have our 3. You substitute for your x, which is 2 plus 2 mu, minus our y, which is negative 1 plus 2 mu, then plus your z, which is 2, into z, which is 1, minus 2 mu, equals to z. Now, the first thing you need to obtain is your mu. So you open your brackets very, very well. So we are going to open our brackets. So we shall have our 6 plus our 3 mu minus this negative and the negative will yield a plus. This negative and a 2 will yield our 2 mu. Then plus here we shall have 2 minus our 4 mu equals to 7. Now at this point, you are going to collect your like terms that have 6 plus 1, which is 7, plus 2, 8, which is 8, 9. So we shall have our 9. So 3 mu minus 2 mu minus 4 mu. So that is, this is negative 6 plus 3 mu, which will give us minus 3 mu equals to 7. So here you are going to collect your terms. Negative 3 mu will equal to 7 minus 9. So you get negative 3 mu equaling to negative 2. So you divide through by negative 3, divide through by negative 3 this side. So at the end of that day, you'll have your mu equals to 2 out of 3. Now, dear students, whenever you are continuing to use any variable, always avoid having a decimal point. Don't go on and write your decimal points. Always carry your fraction such that you can be very, very accurate. Now, what are we looking for? Now that we have obtained our value of mu, we are going to find out where are they meeting. So mean that in order for us to get the meeting point, we are going to come back here and obtain the meeting point. So we are going to substitute our mu into our equation for the line. So I'm going to come here and I say now our x, y, and z will equal to 2 plus mu. So where there is mu, we put 2 out of 3. Negative 1 plus 2 times 2 out of 3. Then 1 minus 2 times 2 out of 3. So here we shall have our x, y, and z equaling 2. So 2 plus 2 out of 3 will give us 8 out of 3. Negative 1 plus 4 out of 3 will give us 1 out of 3. And then 1 minus 4 out of 3 will give us negative a third. Now, this one is going to be our point P. So meaning that your point P is going to have the coordinate of 8, 3, 1, 3, and negative 1, 3. And this is the point where the plane meets with the line. Like I showed you at first, that you have your house. This is our greenhouse. And there is a pipe passing through it inside. So that means that this point where this plane here, this plane of ours in 3 dimension meets with what? With this pipe. This is where we have our point P. And in order for us to find a point of P, it means that we have substituted our x, y, and z into the equation of the plane. So in other words, you are looking out for how do you find a point of intersection of a line and a plane. So the point where the two things meet, you get a point. Remember earlier on, we said that a line and a plane, once they meet, they are going to form a point. So that point that they form is this point, what we are calling point P. Kindly let me know through the chat whether we are on the same page. In case there is anything that's not yet clear, feel free to raise up your hand. Okay. Okay. Yeah. Okay. Members are saying that they are not seeing the work I'm writing. Kindly confirm. Okay. Okay. I think. Okay. People are saying, Melissa is saying the work same page, same page. Okay, good. So now that is the point. Now, after obtaining that point, you are going to go on and now find what is the distance. So now, like I told you, always you must communicate. So you are going to come here and say, now obtaining the distance, obtain the distance between S and P. always communicate what you are working out. So we have our point S, which is 1, 3, and 2, and we have our point P, which is 8, 3, 1 out of 3, and negative a third. So to obtain our S and P, SP is the same as our vector S to P. So first find out what is SP before you go on and find the distance. So there are two ways you can do it, but I'm going to use both approaches, and then you will choose which one you want to obtain. So to obtain SP, I can say that SP is the same as obtaining our vector O to P minus O to S. But please feel free, since we are going to obtain distance, someone could have said also P and S. So what is O to P? O to P is 8, 3, 1, 3, and negative 1 to 3. And then I'm subtracting minus OS, which is 1, 3, and 2. So when you subtract, we shall have now here 8 out of 3 minus 1, a third minus 3, and negative a third minus 2. So you place your calc very well. So when you place your calc, 8 out of 3 minus 1, you get 5 out of 3. A third minus 3, you get negative 8 out of 3. Negative a third minus 2, you end up with negative 7 out of 3. Now this is your SP. Now in order for you to get the distance is going to be the magnitude. So I'm going to say our distance SP magnitude is the same as having your x squared plus the y squared plus our z squared. So now please show all your working. So we shall have now 5 out of 3 squared plus negative 8 out of 3 squared, then plus negative 7 out of 3, everything squared. So when you continue, we shall have 5 out of 3 squared, which is 25 out of 9, plus 8 squared out of 3, which is 64 out of 9, plus that is 49 out of 9. So which when you work out 25 plus 64 plus the other one is 138 out of 9. So here, when you place your calc, you'll end up with the, let me first write it as 1 out of 3, which is the same as 3.91578. Now that is what you are going to write. Now in case they had given you units, let me say this question had given us maybe the units. Now when you check through, you may note that the units are in meters because they want you to compare things in meters. So meaning that if they did not mention it here clearly in the question, but when you look at what you are obtaining that is going to be in meters, then we shall go on and put that here our distance is going to be in meters. Now after doing so, you are going to go on and make a conclusion. You need to decide, because the question wanted to find out the extension worker wishes to move the sprinkler closer. Now that means that your decision is going to be taken basing on that statement. If the distance between S and P is more than 5, so we are going to come here and we make our decision basing on that. So we shall make our conclusion and say that since 3.91578 meters is less than 5 meters, what will happen? Because they told you if it is less, so we shall say that the extension worker should not move the sprinkler closer, because they have told that if it was more than 5 meters, they would have moved. But since it is less than that, then there is no need for why the extension worker should go on to move the sprinkler. So that is how you can obtain it. So someone could have done in that particular format. But still, even when it comes to distance here, dear students, there is no harm for you to tell us that the distance SP can also be given by using this. I know you can use x2 minus x1 squared plus y2 minus y1 squared, then plus z2 minus z1 squared. Dear students, this one is also very fine. You could do it this way, also you get the same answer. So you can use any of the two approaches to get. Now, what is the best approach that I would recommend? I would recommend this. Why? Because here, in case God forbid you make any errors you make any errors along any path, you can still get a score somewhere that you obtained your SP. They can give you a score for this manipulation. However, when it comes to this one, when it comes to using this approach, remember you are going to substitute things directly at the same time. So mean that any error you make at any step, you are going to lose out everything. So you need now to be very calculative which approach I'm going to use for what particular number. Okay. So in case you have any questions, feel free to ask. Otherwise, let me know whether we are on the same page. Are we on the same page? Okay. Okay. People are saying we are good. Are we allowed to use symbols? Use symbols after you have defined them. That's why here I've said distance, SP. So that's when I can go on and use. So use symbols after you have defined it, Dr. Peace. Oh, like less than, oh yes, these are mathematical symbols. Less than and greater than are mathematical symbols that are well known. So that one is very okay. But if you want, you could also write it. Okay. So we are going to continue to the second part. Now, when we go to the second part of our scenario, I'm going to first take you back to the scenario. The second part or the second paragraph here told us that two boundaries of the sprinkler spray zone on the greenhouse floor have equations. So they have these two equations, y is equal to x minus 1 and this. The extension worker wishes to change the zone nozzle if the angle between the two spray boundaries is less than 50 degrees. Now, when you look at this concept is about finding the angle between two equations. Now, when you look at these two equations, this is your first equation, y is equal to 2x minus 1. Then the second equation is 3x plus 4y is equal to 8. When you look at the two equations, these two equations are equations in this form of mx plus c, meaning that these are equations of a line. You are going to ask yourself, how do I find the equation of a line? Allow me to first give you a brief because I don't want you to cram. In case this is my plane, my Cartesian plane in 2 dimensions, and I have a line, let me say this is my line. And this line here makes an angle. Let me say this angle, I can call it angle alpha. And this, I have another line. Let me say this is my line. And this line here makes an angle which is beta. This is line 1. This is line 2. And this is my line 1. Now, in case I want to obtain the angle between the two lines, the angle between those two lines is this angle here, which I can call theta. So, members, how do I get theta? So, in order for me to get theta, I need to first find out how am I going to get theta. So, from your mathematics, you can tell that the angle at this point here, this angle is going to be 180 minus beta. So when you look at what my lines are formed, they are formed a triangle. So you know that angles in a triangle add up to 180. So what does it mean? It means that alpha plus my 180 minus beta plus theta I must be able to get 180 because angles in a triangle add up to 180. So what shall we have? We shall have alpha minus beta plus theta equaling to our 180 minus 180. What do you end up with? You get alpha minus beta plus theta equaling to 0. So if you make theta, because you are interested in the angle between, theta will equal to, when I cross this side, I'll have my beta minus alpha. Now, what do you know about a straight line? You know very well that when it comes to these straight lines, I want you to understand, don't cram. When you look at the first line that I have, this is my first line I have. For I'm looking at line 1. So line 1, let me say this is my y1, and from here up to here is where I have my x1. So I know very well when I'm to use the trigonometric identities, I can say that my tan of alpha is equal to my opposite out of the adjacent. But when you look at y1, y1 is the same as the change in y. When you look at x, is the same as the change in x. Now, change in y out of x is what we call the gradient. So meaning that your tan alpha is the same as m, where m is the gradient. So here for the first line, I can call it m1. Similarly, if I had for line B, still I will say that for my tan of beta, in case this is your y, for the second line, I can call this y2 and I can call this distance here to be x2. So tan beta will be y2 out of x2. So meaning that your tan of beta will equal to your gradient, which we can call m2. So that means that for the first line, it will have our gradient m1. For this second line, I'll have its gradient called m2. Now, if I introduce tan here, it means that I'm going to have my tan of theta equaling to tan of beta minus alpha. Now from here, you remember your identities of tan. That if I have tan beta minus alpha, what do I get? So that is where now we are picking the idea that if I'm subtracting two things in tan, what shall we have? So from here, we shall have that tan of theta will equal to our tan of beta minus my tan of alpha, everything divided by 1, plus my tan of beta, tan of alpha. So what happens that where there is tan beta, you say the tan beta is m2, you say the tan alpha is m1. So meaning that here now you're going to come and say that now my tan of theta is equal to tan beta, which was m2, minus your tan, which was m1, divided by 1 plus your m2, m1. Now members, this is where that relation comes from. Whenever you meet that you have two lines and you are looking for to obtain the angle between, this is what I want you to use. And I want you now going forward to always come on and put the magnitude. So that is how we find the angle between any two lines. So whenever you meet any two lines, I want you to remember that, and it comes from the subtraction of tan. So always up, the two gradients you have, you must always subtract them. Please take note, you must always subtract them. It does not matter which gradient you subtract first. As long as you have the magnitude, the answer will always remain the same. Hope members we are on the same page with that. Are we on the same page with that as we dig deep? Okay, members are saying yes. So I'm going now to clean my screen. I'm going to clean my screen and then we start. So when you look at the question, they told that if the angle between the two split, so that's why we have gone on to find the angle. So I'm going to come and I first express each of these two lines in form of y is equal to mx plus c. So when you look at the second line, it's not in this form, so you have to first express it in that form. So we shall have 4y equals to negative 3x plus 8. Now, y must be independent, so we shall say y is equal to negative 3 out of 4 of x, then plus 8 out of 4, meaning that this line can be written as negative 3 out of 4 of x, then plus our 2. Now, this is your first line, and this is your second line. May I ask each one of you through the chat to place for us what is the gradient for the first line and what is your gradient for the second line? What is your gradient for the first line and what is the gradient for the second line? Isaac? Okay. Isaac. Yes, Isaac?
Good morning, sir.
Yes, good morning.
Sir, the things are not clear. We are not seeing what you are writing.
You are not seeing completely what I'm writing.
Yes.
Oh, maybe Isaac, it might be from your ends. What are you using? A
Mm.
phone, laptop?
A phone. I was clear, but now when you we change to this page, the things are not seen now.
Oh, now you look for the screen. You look for my screen.
Okay.
Let me try to spotlight. Are you able to see it now?
Yeah.
Okay. Okay. Thank you.
Thank you, sir.
Okay. So now, thank you, members. I've seen. So what are you going to do? Remember, I've told you you must communicate. So I'm going to come and say, obtaining the angle. Now, please, you take note. Here, I'm going to say the angle theta. Here, I'm defining what I'm finding. So I'm saying obtaining the angle theta. Allow me to divide my screen. The angle theta between the two split boundaries. I'm now communicating what I'm working on. So I've defined that my angle is going to be theta. So now I can write my formula very well, that tan theta is equal to the magnitude of m2 minus m1 out of 1 plus m1 m2. So we have said that our first gradient, M1, members have given it as 2, and your second gradient, M2, is negative 3 quarters. So where there is M2, you substitute. So we shall have our tan theta equaling to the magnitude, negative 3 out of 4, minus our 2, divide by 1, plus your negative 3 out of 4, then times the 2. So you do your math. So this is going to be our tan of theta equaling to the magnitude. This is negative 11 out of 4. Divide by down, that is negative a half. So here, when you continue, your negative and negative gives you a positive. So here, you'll end up with 5.5. And this is your tan theta. Why we are putting the magnitude is to eliminate any negative that you may get. So that's why we put the magnitude. So here at the end of the day, you are going to have your theta equaling to the tan inverse of 5.5. So here we shall go on and obtain our theta, as tan inverse of that is going to be, place your calculators, place your calc. Let me also first get my calc here. So when you get tan inverse of 5.5, tan inverse of 5.5, you end up with 79. So I write here, this is 79.695 degrees, which you can approximate to 79.7 degrees to 1 decimal point. Now, And here, when you are working on this, always you can even go on and make a simple sketch and say, now this line here has a positive gradient. You can first sketch it and say, this is my line, y equals to 2x minus 1, and it is taking on my gradient m1. This is maybe my second line. Maybe you can draw it the way you want, like this, and you say this is your angle theta, and this is your line, y is equal to negative 3 out of 4x, then plus 2. And this one is taking your line M2. You could come up with a simple sketch such that you clearly show what your M1 is and what your M2. So after you getting the angle, please don't stop here because there is another score you need to look out for. So they told that the extension worker wishes to change the nozzle if the angle between the two splay boundaries is less than 50 degrees. Can we have a volunteer to give us now what would be your conclusion? And what decision are you going to make? Someone can raise up the hand and then you share with us. What is going to be your conclusion for this? Okay. Yes, Jonathan?
My conclusion,
Mm.
I will conclude as saying that the extension worker
Mm-hmm.
should not change the nozzle
Mm-hmm.
since the angle is more than 50.
Okay, very good. That is one way you can conclude. Dr. Jimmy, thank you. Dr. Jimmy? Okay. Okay, I'll fail to get Dr. Jimmy. Waswa?
Morning, sir.
Yes, morning.
My conclusion will be the extension worker will not change the nozzle since the angle between the spray boundaries is above 50 degrees.
Okay, very good, very good. Now, in each of your conclusions, members, I want you always to include in your answer. You compare. Now, don't just tell us that it is because it is more than 50. What is that is more than 50? So put that angle, that 79.695 is more than 50 degrees. So you could say that the extension worker should not change maybe should not change the nozzle. Why? Because the angle between the the angle 79.7 between the two splay boundaries is more than 50 degrees. So there you have made your conclusion and you have made a decision. What decision have you made? That the workers should not change the nozzle, and you have given us the reason. So make sure that for whatever conclusion you are making, there is a decision made and you have a reason why you are saying so. There is a decision you have made. Here. Our decision is he should not change. That is the decision. Why? That is the reason. Why? Because the angle you have obtained is more than the threshold that was given. So that is how you can conclude on that. Okay, so members, are we good to continue? People are saying we can continue. Okay. Now, we on this item, now we have another part. They went on and told us that during calibration, the sprinkler rotates through an angle x, which satisfies the equation. This is the equation. 2 sine x plus 5 cos x minus 1 is equal to 0 between 0 and 180. If the angle is less than 100, the sprinkler will be adjusted. So what are you getting? Here they are indirectly asking you to solve for the value of x, find out the angles you are obtaining. So here I want to first remind you of a few things. Number one, when we are working out angles, you need to be well conversant with the quadrants. That's number one. Number two, you need to know which approach are you going to use. We have different approaches. Now, dear students, whenever you find that the equation you are dealing with is, let me say, in this form, let me say this is ax and this is cos of bx in this form, whereby this is ax bx. Here the two approaches you can only use is either r or the t formula. Whenever you find your equation, sine 2x plus maybe cos of 2x, this one should either be r or t. You find things like sine of maybe, and please take note, what should you take note of are the angles, that the angles here should be the same. That one is very key. The angles here should be the same, not you having sine 3x and here you have cos of x. Now here your r or your t is not going to work out. If you find something like sine x plus cos of x, what should come into your mind? That now that is either r or using the t. So that those two things are very important. Diana, you do not have a microphone, so someone can support Diana on how to join using. So please, you have to take note of those two things. So you need to know now, how am I going to approach in case I meet such a case? Yes, Jonathan.
Sir,
Yes.
I'm just asking whether both R and T, they give the same answer.
The answer is yes. All of them give you the same answers. You get the same answer. So
Yes.
now when you look, okay. So when you look at what we have now here, you notice that they have given us 2 sine of x plus 5 cos of x minus 1 is equal to 0. When you are to use r and t, please always check that these two angles are the same. The moment you find that they are the same and you are dealing with sine and cos or cos and sine, then please choose any of the approaches you want. You can decide to use r, you can decide to use your t. So allow me that for this number, I'm going to use r. Then the next number we shall meet, we shall go on and use our t. So you can use any of the approaches. So I'm going to specify that using our formula. So here you are identifying which approach you are going to use. Now, if you are using our formula, if I have sine and a cos, then I can define that which one can I use? I'm going to first come and say that 2 sine of x plus 5 cos of x can be written in terms of sine, that r sine. Now the first thing is the angle you are dealing with, x. So I will put here x, then I say plus my alpha. So you go back and remember from your expansion, when you add a plus b, when you expand this, what do you get? That this is sine a cos of b plus this is going to be sine of b cos of a. Now, that is the kind of expansion you are going to apply at that point. So, you have to take into consideration all those things. Yes, Samsung?
Morning, Master.
Yes, good morning.
Master, what if I use R cos in brackets x minus alpha?
X minus, it is also
Alpha.
k. You get the same answer.
Okay, Master.
Yes. So here we shall have this as r sine of x cos of alpha, then plus r cos of x sine of alpha. So what are you going to do next? You are going to make a comparison. You are going to compare. So when you compare, like this side you have 2 sine of x plus 5 of cos of x. And what are you comparing with? You're comparing with r sine x cos of alpha, then plus r cos of x sine of alpha. So you compare your sine with the sines this side. So meaning that your r sine of x cos of alpha can be compared to 2 sine of x. So sine and sine can cancel, so meaning that your r cos of alpha is equal to 2. This is like your first equation. Then also compare. Compare this, compare it to that. So you are comparing your r cos of x sine of alpha equals to 5 cos of x. So here when you compare, you have r sine of alpha equals to 5. This is your second equation. Now those two things are very important when you are coming up with your r formula. Yes, Dr. Jimmy?
Master I was inquiring whether we should first write that x and then we add the alpha, or it is now, for instance, it was subtraction. Which one would come first?
Now, in case you are using your x, let me say you have decided to use cos of a minus b. So this would be cos of a. I saying now, in case this is what you are using, I don't know which one you are using.
No, I was just inquiring which one should
Mm.
come first if you were subtracting those two angles.
Oh, in case you are subtracting, like in case it was like this,
Yes, which one would come first?
still sine x will come first, and then after you bring your cos of alpha.
No, I'm meaning there in the bracket there where you have r sine x minus.
Here,
Yes. If you
what
had them
comes first?
if you had a cos the other side and then you had to subtract.
Like, I'm not getting, like, in case you had r,
If in case you had r cos,
what
is
comes
it that
first?
yes.
Your angle you have here must always come first. The angle you have is what comes first, then the other angle comes later.
Okay, Master. Then for this question, this very one, you said that we can again use, you can again subtract somewhere. But Master, when we are comparing there in the R, may we have a negative?
Yes, now if you have decided, for in case someone goes on and say that he's going to use this, are you saying in case someone uses this, still this is going to give you your sine of A cos of B minus your sine of B cos of A. The only difference with someone who goes on with subtraction is that one of these ones is going to be a negative.
Now, can't that negative interfere with the answer?
Now that negative, if you don't know how to deal with a negative angle, it will not take you to the answer.
All right, Master. Then let me wait for the quadrants. Maybe there is where another concern is.
Okay. So from here, and members, I want you always to take note that in case it is a plus, always try your best. Always try that the expansion you get here for your R is also a plus. In case it is a minus, also look for a where you are going to use a minus. But avoid, I want to discourage, avoid having a plus here in between the sine and the cos, and for you here, you are getting a negative because that one will call in for another concept. So make sure that the two signs always align very well. So from our equation 1 and 2, we can now square them. So when you square those two, you get r cos squared alpha is equal to 4, and also you get r squared sine squared of alpha. So this is 4, that is 4, and this is going to be 5 squared, which is our 25. So when you add, we get r squared cos squared of alpha plus r squared sine squared of alpha equals to 4 plus 25. So you know very that this is r squared into cos squared alpha plus sine squared alpha equals to 29. So you know from your trigonometry, cos plus sine is always equal to 1. So you get r squared is equal to 29. And when you get the root, it will be root of 29. Now avoid writing points at anything. So here, take it the way it is. Don't write those points that may be point this, point, leave it like that. Then the next thing, we are going to get the angles. So you are going to divide equation 2 and equation 1. So we shall have our r sine of alpha equals to 5, and we are dividing it by r cos of alpha divide. So this one, we shall have our tan of alpha equals to 5 out of 2, and our alpha will equal to tan inverse of 5 out of 2. So here, what shall we have? We shall have 5 divided by 2 tan inverse of that, which will give us 68.199 degrees. So here I encourage that because you want to be as accurate as possible, the number of decimal places you write for your angle, at least let them be 2 or more than that, such that you are very accurate. Number 3, I want you please to take note that here you have noticed that much as I had obtained my r, I could go back and just use one of the equations and I get my value for r. But I have not used that approach. Why? Because in case there is any mistake I had made in the first calculation, it does not affect my second calculation. So in case here things don't go on well, at least here you'll get a score for finding the angle. So please, you need to be very calculative, that unless you are very sure of what you have done. But if always use the second approach, such that at least you are at an advantage using both ends. Okay, I'm seeing Francis and then Senyonjo.
Good morning, sir.
Yes, morning.
I had 2 questions. The first one,
yes,
on this part where you had using our formula.
Hmm.
Now, on those following steps, I was asking, aren't you supposed to be using the equivalent symbol instead of the equal signs?
Yes, equivalent is the best.
Oh,
Yeah.
Then my other question is kind of unrelated, but yesterday, when you were working out yesterday's number, when it was talking about maximizing, which is similar to this, maximizing some stuff of sine. Then you proceeded to go and find this other angle, the alpha angle. But now me, I was asking, was that really necessary to obtain that angle?
Oh, the angle.
Yes, because here it's necessary, but in the other scenario, I was not sure.
Oh, now, why the other side it was necessary? The reason was because you were trying to make this one into a simpler thing.
Yes.
That's why now we had to go and find that angle, because you are trying to make it simple, or you are trying to bring it smaller to what it can be expressed as. So that's why that angle was needed. Otherwise, you cannot just remain with unknown.
Oh.
Yeah. So that's why, because otherwise you were going to remain with x plus unknown, of which now, if you expand that using that unknown, you don't go back to the original thing.
Oh, okay.
Okay. Okay. I think let's first continue. I will answer the rest. So now, after obtaining your R and this, please come back. Come back and substitute them very well. So I'll come back. Oh, wait. I'm going to come back here and say now where there is R, I put my root. So I'll come and say this is root of 29. What is this? This is sine. And this is going to be x, then plus my 68.199, then minus 1 is equal to 0. Now, let me use also what our friend here was telling us. Please and please never leave unknown in your answer when you are expressing, even if it is not needed. For that case, someone could get the answer without it, but still don't leave unknown, because that unknown you have left is not equivalent to the original thing. So here I'm going to go back and say we have our root of 29, our sign, which was x plus 68.199 minus 1 is equal to 0. Since we are solving the equation, we shall say this is root of 29, our sign of x plus 68.199 will equal to 1. So the first thing you ensure, always remain with sign on one side. So we shall have x plus 68.199 is equal to 1 out of root of 29. So at this point, you can now say that this is going to be 6 x plus 8199 is equal to, now what do you have this side is going to be sine inverse of 1 out of root of 29. So what do I want you to always take? Please, when you look at this angle, what you have, this ratio here, it is a positive ratio. Always remember your quadrants, that all, so that means that your sign to this is a positive quadrant. For it to be positive, what do you need to know? That you can have an angle here, you can have an angle here. That is something you need to know when it is positive. But because there is a root here, there are possibilities that you can have a negative, because this root can yield negatives. But because when you look at our range that we already have, it does not call in for negatives. When you look at our range, when you look, it is between 0 and 180. So since it does not call on for negative, then we shall not look at the negative. But next time, they may give you a negative domain. Next time they can give you something negative 180 to maybe 180. Now for such a case, when it comes here is where now you are going to say that because of a square root, it yields a plus and minus. So that one, you'll consider negative 1 out of the square root of 29. Because when you get a square root, you can get a plus or a minus. So in case you have negative 1/8, now that's when you consider a negative. So please, you take note. That's why I kept on this root, because I wanted to show that next time they may give you a domain which has a negative, and then for you will get only positive angles, forgetting that this root can also yield a negative. So meaning that the angles we are going to get can either be in the first quadrant or in the second quadrant. So here when you place your calculator to get this 1 divided by root of 29, and you get the sine inverse, from my calculator here, I'm going to get 10.7 degrees. Now 10.7 degrees is always your first angle in this quadrant. This is the angle 10.7 degrees. Now also on this, along this axis here, the angle you have here is 10.7 degrees. But when we are measuring angles, we measure them clockwise from the positive x-axis here, since our domain is positive. So the first angle we are going to have is 10.7. Then the second angle that we are going to have is this angle that I'm going to move from here up to this point here. So this angle here is going to be, since this line is 180, we shall say 180 minus the 10.7. So what answer will you have? That is going to be 169.3 degrees. So I can go on and find other angles. In case they wanted other angles, still I'll come like this, like this, like this, up to when I meet this line here. So how many degrees? That one would be 360 plus 10.7. That is the other angle you can form. So when you get 360 plus 10.7, here your answer is going to be, this is going to be 370.7 degrees. Like that, like that. So that's how you can obtain those angles. Then, but remember this side, you still have x plus 68.199. And what are you interested in? You are interested in obtaining the positive, you are interested in obtaining x. So that means that now you're going to say x plus 68.19 is equal to 10.7. So here, your value for x is going to be your 10.7 minus 68.199, which is going to give you a negative 57.499. When you go on to get the second angle, when I have 169, I'll have x plus 68.199 equaling to 169.3. So when you get your x, for that case, you have 169.3 minus 68.199, which is going to give you 101.101 degrees. When you try the last one, it's going to be 370.7 minus 68.199. So you notice that this one is going to be 302.501 degrees. So which angles do you have for x? The angles for x, you notice you'll have negative 57.499. You're going to have 101.101 degrees. You're going to have 302.501 degrees. But when you go back to your domain, our domain told us that they want this angle if the angle is less than 100 degrees. So when you look at our domain, the answers we have obtained, ask yourself, do you have any angle between 0 and 180? That yes, there is this angle. So this angle will qualify to be our true value for the x. So we shall now conclude and say our x is 101.1 degrees. Now, after obtaining that angle, then you are going to go on and make a conclusion, and you give a reason, or you make a decision depending on what the item is asking for. Now, there are cases, dear students, where you are going to reach whereby all the angles you are finding are within there's not any angle within that domain. Then there you'll go on and reject it in case there is no angle that follows within that. So here I'm going to ask someone. Let me first pick Papias and then Dr. Jimmy, as someone can write for us the conclusion in the chat. Yes, Papias and then Dr. Jimmy.
Good morning, sir.
Yes, good morning.
I would like to know, understand more on the step where you had to, after getting the time, the angle of turn. So
the angle of turn.
Yes.
Here,
where we got 68.199.
Yes.
The next step.
Or the next step was to come and compare. Like from here, are you seeing from this step?
Yes.
We substituted what your R was, what we had obtained as our R this. We went on and substituted our angle alpha, which we got as this. Meaning that in the position where you have this, you are going to put it this, because this is the simplified form.
Okay. Thank you, sir.
Okay. Yes, Dr. Jimmy?
Master, my inquiry is about those the quadrants.
Yes.
If we had like a sin 3x and we had to look for the angle, how would we get that angle, Master? If the other side, okay, we had like a 3x.
Now, in case, let me say you had a sine of 3x is equal to, let me say, 0.5. So here I will say 3x is equal to sine inverse of 0.5. So here you'll get 3x is equal to, then you say sine inverse of 0.5, which is 30 degrees. Now you come to your quadrants. Identify, because 0.5 is a positive, so sine is positive in the first quadrant and in the second quadrant. Now the first angle you get here is what you call the reference angle. So you are going to place it here that this is 30. You replace it here that this is 30. Is that fine? Now, the next thing now, obtain all other angles that give you sine inverse as 0, that give you sine as 0.5. So you start moving. The first angle here you meet is 30. So 30 is going to be part. Move. The next angle I'm going to meet here is going to be this, which is from here up to here is going to be 180 minus 30, which is 150. So the next angle is going to be 150 degrees. Continue moving. I'll move from the first starting point. I come up to when I meet here. Now the next angle here is going to be 360 plus your 30, which is 390 degrees. Continue moving. Move up to when you reach here. Now that one is going to be 360 plus 150, which is now going to give you 510 degrees. Continue moving. You can turn very many times. Because this is 3 times, it means you can move 3 times. So you move the third time. We have made 2 cycles again. Move the second time. This was 1, 2. Move again. So that, in other words, you're going to be adding 360 from the start. Here, add 360, add 360, like that, like that. Add 360, add 360. So you have 390 plus your 360, you get 750 degrees. 510, add on another 360, you get your 870. Now, all these angles you have obtained, the moment you place them in sine, you'll have your answer as 0.5. So what you do now, since you are interested in x, now you start working out one by one. That 3x is equal to 30. Divide by 3, divide by 3. X is equal to 10. So all these angles, you're going to divide them by 3. So 150 divided by 3, you get your 50 degrees. 390 divided by 3, you get your 130 degrees. 510 divided by 3, you get your 170 degrees. Like that. 750 divided by 3, you get your 250 degrees. 870 divided by 3, you get your 290 degrees. I don't know whether it is clear.
Now, Master, what if it was negative?
What if it was?
Negative.
Now, in case it was negative, still, you'll come and say that 3x, let me say it was sine, 3x is equal to negative 0.5. Still come, check out in the quadrant, where is sine negative? Sine is negative here, and sine is negative here. Now, the use of this negative is to show you which quadrant does your sine fall in. Now, when I'm placing, I'll say 3x is equal to sine inverse of 0.5. I don't place the negative because the negative only shows you the quadrant where it lies. So I'll place sine inverse of 0.5, which is 30. So I'm going to come here and I place here, this is 30 degrees, and also here I have 30 degrees. So I start moving. So when I move, I'll move in the clockwise direction like that. So that is the first angle I'm going to meet. So I will be 180 plus 30. So here, my first angle is going to be 210 degrees. I move again from here up to when I meet here. So how many degrees are those? 360 minus 30, which is 330 degrees. I move again. This is the first cycle. I move the second cycle. I move, that is 1. I come back here. So in other words, I'll have 210 plus 360, I get 570. Like that, like that. Then after I divide by 3, so I said 210 divided by 3, I get my first angle as 70. 330 divided by 3, you get your 110 degrees. So that's how you can do it.
When it is negative, you don't consider the first angle, that 30.
Yes, that first angle shows you the quadrant where your angle lies. That is called the reference angle. So it's not part of the solution, because when you place sine of 30, you don't get negative 0.5. Whatever angle you get here, the moment you place it, you must go back and get the initial ratio. Okay.
Thank you.
Okay. I'm going to pick on just one hand, maybe 14C. 14C. Okay, I'm fading. Jakisa. ask? Okay. I think we are going to move on. We are going to move on. Okay, from Ian, he has told us that the calibration angle is approximately 101.1 degrees. And the conclusion, since 101.1 degrees is greater than 100, the sprinkler should not be adjusted. Okay, very good. So that is okay. So,
Yes, good morning, sir.
yes, morning.
Sir, my question is about the other first part, which at the beginning,
Yes.
I'm asking that, what if the angles they have given us there, they are not the same? Like our 2 sine x plus 5 cos of x minus 1, the angles are not the same. So what do we
Then
do in
there,
that situation?
you apply the identities. I think I will show you one number at the end of this session. I will show you one number of that nature.
Oh,
You use the
okay,
identities.
okay, sir.
Okay, so members, allow me that we continue. Now here, you make your conclusion and then you can say that maybe since 101.1 degrees is greater than 100, the sprinkler should not be adjusted. You always decide, make a decision, and give a reason for your decision. Okay, then we go to the last part. And the last part was telling us that a faulty nozzle sprays water such that it hits the floor at a point Q, whose distance from point A is twice its distance from the point B. And then they went on and told that the extension work wishes to reallocate a plant at 7.4. If water can't reach it, now, what are you going to do? So I'm going to first summarize that what do I have? I have my point Q, which is XY. I have my point A, which is 2, 1. I have my point B, which is 5 and 3. What does the question want me? Now, you read again the item. Don't read it at once and then you go away. Read it until when you feel you have understood. So they told us that it hits the floor at point Q, whose distance from point A. Whose distance from point A? That means that from point Q to point what? To point A. So the distance, so I'm going to say that the distance QA is twice. Twice means what? 2. Its distance from point B. Still, at a point Q, so here we shall say that the distance is equal to twice the distance of this point Q to our point B. I repeat, a faulty nozzle sprays water such that it hits the floor at a point Q. It's like you have a floor. This is the floor. And now this water is coming, something faulty. This is where point Q is, which is X and Y. But they are telling you that the distance from where, the distance at a point Q, whose distance from point A, there is a point A here, which is A. And there is another point B, which is maybe this side. But they are telling you that the distance from Q to A is twice the distance from Q to where B is. In simple terms, that if this is 1, this distance is 2. In case this is 2, this distance is 4. Members, let me know through the chat whether you have understood that the distance QA is twice the distance QB. Let me know through the chat whether we are on the same page with that. Because that, yes, understood. Okay, very good. Members are at the same page. Why? Because now here indirectly, members, there is a concept of coordinate geometry we are bringing in. Now, how do we represent distance? You know that distance is magnitude. So, how do you obtain the distance between 2 points? Now, here is where I want you to be very careful. I always encourage you, you have to be very careful. So for me, I will say, obtaining, I do part per part, obtaining distance QA. So I'll come and say that, how do I obtain the distance QA? QA is given by y2 minus y1 squared, then plus x2 minus x1 squared. I know some of you, you might have used y1 minus y2. It is the same. So here, when I look at my q, this one can be my x1, y1. This one can be my x2, y2. So here I'll have my square root of my y2, which is going to be 1. Y2 is 1 minus x, then plus my x2, which is going to be 2 minus x squared. That is the first thing. Then after that, I obtain my distance QB. I told the reason why I'm doing this is because in case of any errors that you make, you still have a way you can get awarded. So here I'll have my distance, my y2. This is going to be my x2, y2. So here I substitute again in the same equation. Our y2 is going to be 3. So we shall say 3 minus y squared, then plus our 5 minus x, everything squared. Now, after obtaining those distances, you come back here. So here I can put this, that this is distance QB. Remember, the magnitude represents the distance or the length. So I'll come and say that my QA is equal to twice my distance Q to B. So I substitute what I have. So here I have my 1 minus y squared plus 2 minus x squared is equal to twice the distance this side, which is 3 minus y squared, then plus my 5 minus x squared. So what am I going to do next? Here you apply. You need to remove the square root. Now here you remember your knowledge of indices. How do I remove a square root? In case I have a number, let me say y is equal to root of maybe 4. For let me say root of 5. To remove this square root, you square on both sides. So in order for us to remove those square roots, we are going to first square on both sides. So I'm going to come here and I square this side and the other side. So we shall come here, square this side, also you square this side. Now when you square, you know that, let me say you have a root of a is the same as a power a half. But since you have now squared, this 2 and the 2 will cancel. Please avoid doing your primary things that these ones and this one cancel. Where does it come from? It comes from this indices knowledge. So meaning that here at this point, we shall remain with 1 minus y squared, then plus 2 minus x squared. This side, do not forget there is this 2. So here we shall remain with 4, and we shall have 3 minus y squared plus 5 minus x squared. But everything here is being multiplied by this 2 squared, which was out. Members, are we on the same page with that expansion up to where we are now? I think some people are not seeing the work, okay, but I'm spotlighting. Okay, now the next thing you do is your expansion. You play with your expansion, how you expand. But I always encourage, in case you are not sure of those expansions, you do your side work. There is no problem with you doing your side work. Yes, you do your side work, because some of you want to do, you end up making a mistake. So you say 1 minus y. Here you are dealing with 1 minus y squared. Then open the brackets. There is nothing that will harm you. 1 minus y into 1 minus y. Then open, this is 1 minus y minus... there's something I've forgotten here. There is a y here. Then this is y, then plus y squared. Then this is going to be 1 minus 2y, then plus y squared. You can open that way such that you are very clear. So allow me here to just open that this is going to be 1 minus 2y plus y squared. Then this is going to be 4 minus 4x, then plus x squared is equal to 4 here, and then inside this is going to be 9. That is going to be 6y, then this is going to be y squared. Then this side I'll have my 25 minus, that is going to be 10x plus x squared. Yeah, so you open up, for you feel free to open up using those manual way. It is very, very, very fine. So here when I collect like terms, you notice that I'll have my y squared minus 2y, then I'm going to have my x squared minus 4x, 4 plus 1 is going to be 5. This side I'll have my 4, inside the brackets I'll have y squared, plus I'll have x squared, I'll have 6y, I'll have 10x, 25 plus what? Plus 9. What do I have? That is 25 plus 9. I'll have my 30, 34. Now, at this point is where you're going now to open up the bracket such that this 4 affects everything. So here it will be 4y squared plus 4x squared. Then you start multiplying. This 4 multiplies everything. So 4 times 6, you get negative 24y. This is negative 40x. Then that is 34 times 4, which is 136. And this side, you have y squared minus 2y plus x squared minus 4x plus 5. Now, the next thing is to collect like terms. You collect everything and then you work out. So allow me to check whether I have a page. Yes, I have a page here. So allow me to first write this expression somewhere up here such that I can carry it. You'll be collecting like terms. You collect your like terms very well. Collect your like terms. Take the y, take everything to be one side. Take everything to be on one side. So allow me now to go on that screen, and then I first collect the like terms. So collect like terms the way you want. Allow me that now for my case, I want to take everything that I have this side. I want to take it this side. So I have 4y squared. This is y squared. When it comes this side, it becomes a minus. So I'll have 3y squared. I want to take the x squared. This is negative 2y. Once it comes this side, it's going to become a plus. So it will be negative 24, then plus 2, which will give me a negative 22y. Then this is x squared. I want to take it this side. It will become 3x squared. I want to take the negative 4x this side. So since it is negative, once it crosses, becomes a plus. So it's going to be negative 36x. I want to take the 5 the other side. 136 minus 5. It will be 1. Yes, it will be 131. So it is going to be 131 equals to 0. So members, if you have the same, or in case there is something you have not got right, yes. Are we on the same page? Okay, I think we're on the same page. Yes. Now, when you look at this, if I may ask in the chat, which kind of locus is being described? Me looking at it, which kind of locus do you think is being described by this kind of relation? Very good. Yes, because even they may ask you to describe the path, the locus being formed. Now, when you look at it, you are noticing that this is a circle. Now, here we are in coordinate geometry 2, where you learned about a locus. A locus is the path being taken. You know that when water is being sprinkled, it forms that curved path. Now, what are you going to do? Now, at this point here, I can decide if you wish If you wish, you may decide to say, what am I going to do? I can remove the 3's. So in case you decide to remove the 3, it means that I'm going to remain with y squared minus 22 out of 3y plus x squared minus, when you divide through by 3, this is going to remain, this is what, 12x, then plus 131 out of 3 equals to 0. Now, dear friends, I want you to be well conversant with completing the squares. It's going to be very important whenever you are going to be describing locus, whenever you're going to be having these circle issues. Now, what am I going to do? I'm going to use now completing squares such that I can get a clear circle, such that I know where my center is, where the radius is. But I know some of you may want to use the formula. It is very okay if you want to do what? To compare using the formula, there is no problem. But allow me to use the completing squares, then I'll bring in that one later. So by completing squares, it means that here we shall have y minus, this is going to be 11 out of 3, everything squared, minus 11 out of 3, this is negative 11 squared, plus this is going to be x minus, you always divide this by 2. You always divide what you have here by 2. So this is going to be now my 6, everything squared, minus negative 6 squared, then plus 131 out of 3 equals to 0. So here I can write it as y minus 11 out of 3 squared minus, this is going to be 121 out of 9, then plus x minus 6 squared, then this is going to be minus, is that 36? Then plus 131 out of 3 equals to 0. So the next thing I'm going to do, I'm going to collect like terms. I'm going to have this, and this added together. So I'm going to have y minus 11 out of 3 squared plus x minus 6, everything squared. When you combine negative 121 out of 9 plus negative 36 plus that one, I'm getting negative 52 out of 9 equals to 0. Now, for you to get a clear picture, better you start with x then y, because you may easily mix up when you are getting the center. So I can write it in this form, y minus 11 out of 3 squared equaling to 52 out of your 9. Now, that is what you have. So what next? Next, when you the next thing we are going to do is we need to find out. We need to find out, because the path we are obtaining, or the equation we have obtained, this is an equation of a circle. That is something you need to know, that this is a circle, a circular path. So this is a circular path whose center is 6 and 11 out of 3. That is the meaning. That now the center for our x and y is 6, 11 out of 3. And when you go back to the item, they told us that the extension worker wishes to locate a plant at 7.4 if water can't reach it. In other words, now let me say now you are going to have your circle. This is the circle we have, whose center is 6 and 11 out of 3. But there is a point that has been allocated, and this center has a radius. Now this is to get your radius here, you remember it must be squared. So here our radius is going to be root of 52 out of 3. That is the radius. Please take note that it's not 52 out of 9, because you have to square this. So when you square root 52 out of 3, you get back this. So this is your radius. So our radius is root 52 out of 3. Now we need to find out that if this point that has been allocated, this point which is 7.4, we need to find out that is it within this boundary or it is outside. That's what we need to find out. So that's what you are going to be testing out. So in other words, you are going to find out what is the distance from the center here, 6, 11 out of 3, to this point here, which is 7 and 4. So that is what you are going to first obtain. Now, if you get that distance, you are going to compare. Is it within still the boundary? Because when this water is trickling, coming around, you need to find out, does it reach this point or it does not reach that point? So that's what you are going to obtain. So you are going to come and say now, obtain the distance from the plant, which is at 7, 4, and the center of where the sprinkler is being placed. That's where the sprinkler is. So now that distance is given by, you are going to get your root, your y2 minus y1 squared, then plus x2 minus x1 squared. So here we shall have our root. Any can be your y2, y1. There's no problem. You can say anyway, anyhow, the way you label your thing, it doesn't matter. You can say this is x2, y2, x1, y1. So here I'll have my 7 minus 6 squared, then plus our y2, which is going to be 4 minus 11 out of 3 squared. So this is going to be 1 squared, then plus that is 1 out of 3, everything squared. So here we shall have the root of 1 plus this is 1 out of 9. So when you do the math, remember when you do the math, this gives us what? 10 out of 9, but under a root. So now you are going to compare that this is 10 out of 9, which you can give us root of 10 out of, this is what? This is 3. Now you are going to compare this, and you compare with root of 52 out of 3. And compare the two and check, are they within? So another person, okay, let me not use 52 out of 9 and the other one, because that someone could compare them. So when you look at root 10 divided by 3, here your answer you get is 1.05409. When you compare the radius, how far the water can go, it is 2.403. So here the radius for this is 2.403. Now the distance from this center to where this point has been allocated, it is at 1.05. Now you have to go back and ask yourself, does water reach that point or it does not reach it? So can someone tell us? Or you can use the chart. You can use the chart. Baswali, you can ask. And Dr. Jimmy, yes.
Here, when we were obtaining the radius,
yes,
you squared, but you didn't. You squared only the radius 52 over 9, and it's a bit confusing me. I'm asking myself why.
Why? Now, when you go back to the standard equation of a circle, it will give your radius is going to be r squared. Are you seeing that?
Yes.
Your radius is r squared, and it is always what is equal this side, which is 52 out of 9. So to get your radius r, you take a square root, So your r becomes root of 52 out of root of 9. But root of 52 is not exact, so that's why I leave it. Root of 9 is 3.
Okay, thank you, teacher.
Okay. Yes, Jimmy, and then Josephine.
So my inquiry was there where we completed the squares.
Yes.
What already determines that the sign on, for instance, there, that thing is of making me not see.
Here.
What
this negative?
What determines that negative sign on 11 over 3?
Now, always you carry this. Are you seeing this?
Yes.
That is always what you carry. Now, here, since it is negative, that's why we have negative. But you get this coefficient of b divided by 2a. So when you look at, let me use this. I have y squared minus 4y. Now for this case, your a is 1. Your b is negative 4. So in case I'm completing squares, I'll say b out of 2a. But what is your b is negative 4 divided by 2 times 1. So this is negative 4 out of 2, which is negative 2. So here when I'm completing squares, I'll say y squared minus 4y minus negative 2 squared plus negative 2 squared. Then when I reach there, I'll just combine. Because when you look here, you minus and you subtract. But now the best completing squares, always I will encourage you start with a plus, then you bring a minus. Let me give you another one. Let me say you have y squared minus 6y and you are completing squares. Obtain your a is 1. And always when you are completing squares, make sure that your a is 1. And make sure that your a is 1. So now you obtain the coefficient of b out of 2a squared. So what coefficient do you have? B is negative 6 divided by 2 times 1. So this one, but squared. So here you end up with negative 3 squared. So when you come here to the original thing, say y squared minus 6y, then plus negative 3 squared minus negative of 3 squared. So for you, what you do, you combine this and this. So you just come and say, since all of them are squared, it is going to be y minus 3 squared. Minus now, you bring back this.
Then master.
Yes, please.
That one that you have added, that 3, you have squared it. I think it's positive. Then where does that negative come from?
Remember, you add negative 3 squared minus negative 3 squared. You notice that this is a 0. And this is what you are trying to create.
Okay, master. What is confusing me is that you had y squared minus 3, then plus 3. Then plus bracket negative 3 squared. And then when you combined, you had y minus. When you combined, you had y.
Are you seeing this? When you square this, you end up with y squared minus 6y. Are you seeing? Then plus a 9, which is a complete square. Now, this is what we have expanded. But outside, I've said we shall have also minus 3 squared. So when you expand it again, you'll have this minus. So this is negative, which is minus 9. So this one and this one cancels. So you go back to the original thing.
Right, master.
Okay. So now, yes, I'm looking through the chart to check. So my conclusion, sir, since the point from Travis, since the point is at a distance 1.054, which lies within the range of the radius where the water hits, the water can reach at point C and no need for extension work to relocate the plant. Very good. Yes. Josephine?
Good morning, sir.
Yes, good morning.
My concern, I think I got confused from the point after us finding the radius. Then I don't know why we included this distance, and then from there, I beg your pardon.
Now, Josephine, what we obtained was that the water, when it is sprinkling, it forms a circle. Did you get that point?
Yes.
Now, it is sprinkling. Then they have told us that there is a point that the engineers, the extension workers have obtained, which is 7.4. Are you seeing this?
Yes, teacher.
But now they want to know whether water reaches this point or it does not reach there. Now, how do we obtain that the water reaches there? We need to know where the sprinkler is. The sprinkler is at the center here, which we obtained as 6 and 11 out of 3. Now, for us to know where the water will reach here, we need to calculate the distance from the center up to where that point is.
Oh, yes.
Are you getting it?
Yes, teacher, I've understood.
Now, once that point is within that boundary, then it is an indicator that water can reach there because it is within the radio distance.
Yes.
Another alternative some people can substitute for x and y in this equation of a circle, and then you conclude. But though it's not the best conclusion. Okay. Then lastly, bands. Okay. Samsung. Okay. Let me hope now, members, you have concluded. So I'll expect you to say that the plant. Yes, Samsung.
But master, when you substitute in those values for 7 and 4, you get a negative value. You don't
Now
get
the negative.
0.
Yes. Yes. Now the
You
negative
get a
value.
negative value, not 0.
Yes, like when you substitute 7 and 4, you'll get a negative value. If you get a negative value, it shows you that it is within the boundary. Understood? Okay. Yeah. So when you substitute, but I've told that that's not the best conclusion because always better you compare with the distance. But when you substitute here, once you get a negative, it is within. You get a positive, it means that it is far away. It is out of the zone. That is the meaning. Okay, so that is how you can do, but do not forget always to make a conclusion, make a decision, and give a reason. That the plant at 7.4 doesn't lie on the path described by the faulty nozzle cycle. Even to be an extra student, you can even tell us the path that doesn't lie within the circular zone. Therefore, water can't reach that plant under the given condition. So the extension worker should not reallocate the plant. Okay, thank you. Now we are going to look at another item. We are going to look at another item. Oh, no. In fact, we are still on the same. Is it the same item? No, I think that this is another item we have that I want you to read through. This is another item we have that you can read through. First, read through. This is the other item we are going to do. Read through, read through. Okay. Now, when you read through, they are telling you that a technology company in Kampala is developing mathematical models to transport drone navigation, spotlight calibration, and urban infrastructure planning. 2 drones are launched from different locations to monitor an agricultural demonstration farm. These flights paths are represented by the vector equations. Like we say that always item 1 is going to have those things of trigonometry, vectors, coordinate geometry. So you need to be in position to answer or to respond to those. So you first read it through as we start to unpack the question. HMD, you can ask. Okay, so I think we are going to first continue. So now when you look at the tasks being given, they are asking you that, will the controller approve the proposed drone routes? So now, like I said that always, in case you find that it is not a block question, you need to go paragraph by paragraph such that you respond. Sometimes you may get a block question whereby here they have told you that support the engineer, and that is the task. Meaning that you need to go back, answer every problem in the scenario. So here they are telling us that we have two drones that are launched from different locations, and these drones are going to monitor the demonstration farm. These flight paths are represented by the vector equations. These are the two equations. Now they are asking us that the controllers will approve the proposed flight routes only if the two drones meet during the operation. Now here they are indirectly asking you, do you know how to obtain the point of intersection when you have two vector equations? Do you know how to obtain the angle between the two vectors? Now, that is what the question is asking you. That is the knowledge behind that you need to know. How do I obtain the angle between the two? How do I obtain the angle between 2 points or two vectors? And how do I obtain the what? The point of intersection? And that's what we are going to do. So that is the first thing we are going to work out. So you have to first write your two equations, two vector equations, and then find out whether they meet or not. And what do you base on to see whether they meet or not? So I'm going to come here and I look at the first part. So the first part, I'm going to go on. Like I told you, have to communicate. Communicate what you are doing. So I'm going to say checking whether the now like I told you, always stick to the language being used. Whether the flight paths meet, because that is your intention. That's what you want to find out. So that's why you have to communicate. So checking whether the flight paths meet. So you have your first flight path of R1, which is given by this. So you are going to allow me that I'm going to first extract it. Always learn to extract your data the way you have it within the scenario. So extract your data, that is R1, and then you have your R2, which is negative I plus 3j plus 7k plus mu into negative 2I plus j plus 2k. So what are you going to do? Now you are going to first combine such that you know your x, y, and z. So I can say that now my R1, I can write it in this form: 1 plus 2 lambda, negative 2 plus lambda, and then I'll have 3 minus lambda. Then what is going to be my R2? My R2 is going to be negative 1 minus 2 mu. Then I'll have my 3 plus mu. Then I'll have my 7 plus my 2 mu. So what happens that you need to remember that at meeting point, the x of the first here, this x here is going to equal to the x here. The y here is going to equal to the y. And the z here will equal to the z I have at that point. So I'm going to come here and say that at meeting point, what happens? My x direction is equal, for the first path is equal to the x of the other path. So I'll come and say 1 plus 2 lambda will equal to negative 1 minus 2 mu. So I form that first equation. So I'll have 2 lambda plus 2 mu is equal to negative 1 minus 1 is, when you take this one, it becomes negative 2. So which you can now reduce this by lambda plus mu is equal to negative 1. So this is your first equation. Go to the second one. Negative 2 plus lambda is equal to 3 plus mu. So you are equating the y and the y. So this will be lambda minus mu is equal to, this is going to be 5, and this is going to be your second equation. Then if you want, you can form the third one as well. 3 minus lambda is equal to 7 plus 2 mu. So mean that you have negative lambda minus 2 mu is equal to 7 minus 3, which is going to give you your 4. This is your third equation. Now, what are you going to do? You are going to solve these equations simultaneously. Feel free to use any of the pairs you want. So you can either use pair 1 and pair 2 or pair 3. So I'm going to say now, solving equation 1 and 2 simultaneously. Simultaneously. So I will say using elimination method. Using elimination method. So I'll come and say lambda plus mu is equal to -1. Lambda minus mu is equal to 5. So what am I going to do? Since the coefficients are the same, signs are different, I can first add. So when I'm adding, I say lambda plus lambda, which is 2 lambda, -1 plus 5, that is 4. Meaning that here my lambda is going to be 4 out of 2, and lambda will equal to 2. I use one of the equations to get mu, so I have lambda plus mu is equal to -1, 2 plus mu is equal to -1. So my mu here, when I take that to the other side, to be -1 minus 2, which is going to be -3. So that is your lambda and that is your mu. So in order for you to prove whether it is true, you can now come get your lambda and mu. You get your lambda, get the mu, you can substitute them here and see whether you get 4. You can check it from there. So when I check from there, I'll have -2 minus 2 times mu, which is -3. So this is -2. -2 times -3 is what? 6, which is 4. So meaning that they do the meeting. So what are you going to do? After you obtaining your lambda and mu, remember what you have to do, you need to verify. So I want you to be that extraordinary child. So you're going to say verifying whether they meet. So I'll come here and say, and I write that verifying whether they meet. Like I can use the third equation that I had formed. So that is the one I'm using. Instead, you show it negative lambda minus 2 mu is equal to 4. So you have got your lambda as it was what? It was -2. It was 2 minus 2 times -3. So here we shall have -2 plus 6, which is 4. And therefore, you'll say that since lambda and mu holds for all the values, for all the 3 components x, y, and z, therefore they do meet. Now what next? You need to go on and find what is the meeting point. That's what now you need to understand, that yes, you have found out that they meet, but what is that meeting point? So I'm going to come and say obtaining the meeting point. These are the extra things you have to do. So we shall say that since our R1 was 1 plus 2 lambda, -2 plus lambda, and then 3 minus lambda. So you substitute in your values. This is 1 plus 2 times 2. This is -2 plus 2. And this is going to be 3 minus 2. So meaning that your R1 is going to be 5, 0, and 1. So this is now your meeting point. But still, you can go on. Remember, I want you to be that extra child. Using this is a correct approach as well. This is a correct what? Approach. But now I want you to do the one that will attract. Then for R2, you had -1 minus 2 mu, 3 plus mu, and then the 7 plus 2 mu. So here you are going to have -1 minus 2 times -3, 3 plus -3, and 7 plus 2 times -3. So what are you going to get? Also, you shall have 5, 0, and 1. And that is your R2. Now, this is the best way to make your conclusion. Using these ones, whether the two drawings meet. So you will say that the two drones meet at point. Remember, this is a vector, so you need to write it in a coordinate. So you'll say that the two drones meet at a point 5, 0, and 1, because you can note that R1 holds and R2 holds, and you give the reason why do you think they meet. It is because your R1 is equal to R2. Now that is how you obtain. But remember, they went on and asked you that also find the angle between their roots if it is at least 45 degrees. So now you're going to go on. Like I've said, always define what you are doing. So I'm going to say obtaining the angle theta between the drawn roots, Now remember, when you are obtaining the roots, always we use the direction. So when you have your vectors, we say that this one which has the constant alpha lambda is what we call the direction. So this is your first direction, which I can call D1, and this is what is my direction, D2. So in order for us to find the angle, we are going to find the dot product. So I'm going to come here and say let my D1 equals to 2, 1, negative 1. And let my D2 equals to negative 2, 1, and 2. These are the direction vectors for the two flight paths we have. Then from here, you bring in now your cos of theta. From definition, you have D1 dot D2. What do I want you to take note? That always here, we consider the magnitude. Out of the magnitude of D1, magnitude of D2. So like I've said that always, it's a good practice. Do one by one. So I'm going to first come and say D1 dot D2. What do I have? I bring my direction vectors, 2, 1, negative 1. I dot it with negative 2, 1, and 2, such that I don't have any challenge. So I say negative 2 times 2 plus 1 times 1, then plus negative 1 times 2. So here you'll end up with negative 4 plus 1 plus negative 2, which will give us a negative 5. Then from there, also I'm going to find out what is my D1. Magnitude of D1, so you come and say, now magnitude of D1 is going to be my square root of 2 squared plus 1 squared plus negative 1 squared. And this one will give us the root of 6. Okay, I want to know whether members we on the same page up to that point. Sona Prince. Sona Prince, unmute. Okay. Members, are we together up to that point? Why do we use cos? Thank you, Timothy. Why are we using cos, not sine? Because this is a dot product. We are finding the angle between two vectors. Like if you remember very well, that in case this, I'm going to use this as my direction. Let me use this. This, though I'm not going to show you how it comes. This is your direction, D1, and this is your direction, D2. So to find the angle between the two, which we are calling theta, here we use the cosine. We use cosine. You only use sine when you are using the cross product. That's why we shall use the sine. Okay. Yes, continue.
Yes, Master, good morning.
Morning.
Yes, like I'm running out of battery, but can I get this video? Because it is at 3%.
Yes, will be available online.
Like I just search on YouTube for lesson 2. Yeah?
You got yes, holistic learning platform session.
Okay, thank you, sir.
Okay. Okay. Entire school. Members, you can be completing.
Like the things are clear are not so clear.
Like which one?
Like why the problem is on your PC, we don't know, but you're not seeing all the things.
You are not seeing anything? Oh. I think it might be on your end. It might be on your end because I feel others are saying well. Okay, people are saying it is clear. Maybe you can check. Okay, I think it is your network, that side. Yeah, sorry about that. Okay. Oh. Check out the problem is that side. Okay, so members, we are going to continue and complete. We are going to continue and complete. So now after that, we are also going to get for the second direction, the magnitude of D2. And here we had our negative 2 squared plus 1 squared plus 2 squared. So this is going to give us root of 9, which is going to be 3. So then you go back to your formula that cos of theta is d1 dot d2. Don't forget to put the magnitude out of d1 and d2. So here our dot product is going to be, remember you got negative 5. Why I'm emphasizing to put the magnitude, some of you are going to just multiply, take the negative 5, which will be wrong. Yeah, so this is 3 times root of 6, and this is cosine of theta. So here we shall have cosine of theta is equal to 5 out of 3 root of 6. And therefore, we shall now say theta is cos inverse of 5 out of 3 root of 6. So you go on and get your answer for that. So here, I'll have 47.124 degrees. Yes. And now I know those members who have not put that, who forgot to put, you will notice that your answer is not going to be like ours. If you don't put the what? The magnitude. So please put or raise the magnitude. So from there, the next thing we are going to do, we have to make a good conclusion. A good conclusion, such that we take into account both things. So from there, I don't know whether Wako, you want to give us a conclusion. Wako Simon, who
Good
wants to
morning,
give
sir.
us a conclusion? Yes?
Good morning, sir.
Yes, good morning.
Sir, at the first the question was not clear and we never got it very well. Which mock body was that one?
I don't recall, but maybe I'll check after at the end of the lesson.
Okay, sir. Thank you.
Okay, but I think what was sec, something like that. Okay. Now they say that the controller will approve the proposed flight routes only if the two drones meet during the operation and the angle between their routes is at least 45 degrees. So now you are going to make your conclusion basing on that. So you will say that the drones meet at 501, and since 47.124 degrees is at least 45 degrees, the minimum requirement is satisfied. Therefore, the controller should approve the proposed drone route. Always put the decision and why you are saying so. You can say that the controller should approve the proposed drone routes. Why? Because the two drones meet at a point 501 and the angle between their routes is the angle between the 47.124 is at least 45 degrees. So that's how you can make your conclusion for that part. Are we on the same? It was WENSSEC. Okay, something like that. Okay, so what is the are we on the same page and are we good to continue? Yes, Senyonjo?
Good morning, sir.
Yes, good morning.
What if in the scenario you find that they've not given you the direction vector, but then they've given maybe coordinates? How do you find the direction vector for you to calculate for the angle?
Now, one, if they have not given you, they must give you points. Let me say they have given you the first coordinate as 1, 4, 3, and they have given you the second as maybe 5, 4, 6. So to find the direction, your direction here is going to be AB, is the direction. Hope that is okay, Senyonjo. Senyonjo, is that fine?
Yeah, it's okay. It's okay. Thank you, sir.
Okay. Samsung? Okay.
Good morning, sir.
Yes, morning.
Yes, my name is Jeremiah. And today is my first day, but actually I had a question in the difference between like the direction vector and you find when they give you X and Y and Z.
Now, X, Y, and Z are directions, are individual directions. Let me say, the way you say, this is X, this is Y, and this is Z. Those are individual directions. Then when they give you a direction in a free plane, a direction can be this side, can be this side, can be this side, can be this side, you can go this side, you can go that side. That is now the difference. X, Y, and Z are the standard direction. The way you see that on our XY plane, we can have the X and we can have the Y. Now, this direction here is what sometimes you call the east, and this one can be your north. But these are not the only directions we have, east and north. You can have northeast here, you can have, is it east, northeast, something like that. Hope you have got the difference. Now, all these are directions. Much as also Y is a direction, X is a direction, and Z is a direction. But now a direction vector is that specific direction that a particular vector takes on. Much even it can take on, this one can be your direction, that your vector is moving through that direction. Okay. Hope you have got the point. Yes, Samsung? Is it clear?
So it is, yeah, it's clear, but the question was like, what's the difference between I and I like IJK? Why do we use IJK instead of like, well, like YX? Like, what's the difference between those two? Also, like on the issue of like using cos. So I thought like it is if we are calculating like the same, if they're like the same, we use cos, while if they're like different, if it's like maybe a line and a plane, we use sine, or if it's a line and a line, we use cos. Oh, I'm wrong.
Okay, now I want to bring that whenever you are finding the angle between any two points, the angle between any two directions, let me say this is the angle you are finding. Here we shall use the cos, but that cos doesn't come just like the way you are saying. There is a way we derive it. We derive it there. I don't want to go into that. But when you are finding whenever you are using dot product, let me say this is A and this is B, and you are using a dot product to find the angle between any two, there we always use cos. In case you are finding a cross of two vectors, that's when we use the sine. Number two, when we talk about X, Y, and Z, these ones represent axes, represents positions. That is the meaning. Represents axis or position. When we talk about I, J, and K, these ones represent what we call unit vectors. That is the difference between the two. They represent the unit vectors along the X, along the Y, and along the Z. So that is the difference between two. So in other words, XY axis, they specify where a point is being located. That is what they mean. So XY represent the position. These are positions. Then I, J, and K represent the direction. One is position, another one is the direction. Hope you have got now the difference. If you want to understand it better, this one, X, Y, and Z are scalar quantities. I, J, and K are vector quantities. So when we talk about I, J, and K, still to make it even further, this one is always unit. It is always 1. Like if I say 2I, it means we have 1 and 2. Those are the 2 steps, which is 1. In case I'm denoting X, Y, and Z, I will denote it by, let me say 3, 4, and 5. When I'm writing I, J, and K notation, the direction, I write 3I plus 4J plus 5K. So that is the difference. The difference is in the notation, it is in the purpose. One serves as a position or location. That where is your location? Your location, you are located in Butambala. That is the XYZ. In case I want to know your direction, your unit direction, the I, J, and K, then I'll ask, are you in the east? Are you in the west? Are you in the center? Are you in this direction? Now that is the difference between the two. Okay. So let me hope you have understood the X, Y, Z, and then that. So allow me that, dear friends, we first finish the item. So when we continue to the item, they have told that the same company was contracted to design a rotating spotlight for cultural gala. When you are at school, many times you see those lightings that make circles during those discos that you usually have. During the system testing, the engineers discovered that the rotation angle where A is achieved satisfies this. The spotlight can only be calibrated using the proposed setting. If the rotation angle is between 50 and 55, the engineers need to establish whether the proposed setting is suitable for the spotlighting installed. Now, like I've told you already, the moment you are dealing with cos and sine, and you find out that the angles are the same, that is the first thing you have to identify. And you are dealing with a cos and a sine, then here it is very okay for you to know that you can go on and use either R or you use the T formula. Any of the two. You can use that too. But I want to bring to your attention that if you make a decision, since I've already used R, you are going to allow me that here I use the T. So I'm going to come and say using T formula. Now, when I'm using T formula, I want to bring it to your attention that if it is a single angle, A and A, this is a single angle, your T formula is going to be written in terms of tan of that angle A out of 2. But if these angles were double angles, let me say cos 2A, sin 2A, then there you'd have let your T to equal to tan of A. Please take note. If, let me say, we had sine of 2A plus cos of 2A, and let me say we had 4 here. If I'm to use the T formula, then I will let my T equals to tan of A. But if these angles are single, like the question we have, then there our T will equal to tan of A out of 2. So please take note. So that's why here we are using A out of 2. Now, after you knowing this, don't cram that, I must use this. You go back. I want you always to know the basics. So I'll go back and say now, what do I have? That this is what I have. That maybe, in case this is my what? My tan. This is my A out of 2. What happens that tan, how is tan given? That tan is always given by opposite out of adjacent. So you have T. So your opposite is T, adjacent is 1. So to get your hypotenuse, it means that it's going to be the square, hypotenuse will be what? It's going to be 1 plus t squared. Now, what do I want you to remember? I want you now to remember that in case I'm getting, let me say, cos of A, you need to know that how is cos A related, such that you know how to write it. So that cos A, let me start with the cos of A. You know that cos of A can be written as cos of A out of 2 plus A out of 2. I'm now showing you how things come about. Now, you remember from your trigonometry that if you are expanding cos of A plus B, you say this is cos of A, cos of B, minus this is sine of A, sine of B. That is the knowledge now. So we shall say this is cos of A out of 2, cos of A out of 2, minus sine of A out of 2, sine of A out of 2. Now from here, it is very okay for you to come and substitute cos A times cos A, you get cos squared A out of 2, minus sine of squared A out of 2. Now, if you want, you can fill in from here. If you want, you can continue. So here you can know that what is your cos? Cos is given by adjacent out of hypotenuse. So cos is going to be 1 out of 1 plus t squared. But everything is squared. Minus what is sine? Sine is opposite out of hypotenuse, which is going to be t out of 1 plus t squared. But everything is squared. So when you square, it's going to be 1 out of 1 plus t squared. When you square this side, you shall have t squared out of 1 plus t squared. Because here you need to remember that the square root of 1 plus t squared, once you square it, this is the same as 1 plus t squared. So that is what we have. And now you'll come back and say that since here the denominators are the same, this is the same as 1 minus t squared, everything 1 plus t squared. Meaning that in this position where you have your cos of A, we shall substitute with 1 minus t squared out of 1 plus t squared. Now, when it comes to our sine, you remember from your trigonometry that this identity is very important, that sine of 2A is the same as 2 sine of A cos of A. But if I have a single angle, let me say sine of A, this is still the same as 2 sine of A out of 2, then cos of A out of 2. So that one you need to have it at the back of your mind. So mean that here we shall have 2 sine of A out of 2. It means that sine is opposite out of hypotenuse, which is t out of 1 plus t squared. Then times your cos, which is adjacent out of hypotenuse, which is 1 out of 1 plus t squared. So what is this going to give you? 2t times 1 is 2t. Then root times the root is, they are going to, you have root times the root. So here, down you remain with 1 plus t squared. So that is your sine of A. Now, those two things are very important if you are applying the t formula. That where I have sine of A, I'll put 2 out of 1 plus t squared. Where I have this, I'll put 1 minus t squared out of 1. But how do they come about? That's how they come about. So that is what we call now the t formula. Hope that is very okay. Yes. Now, okay. Now, but if you want, you can use the thing. Someone was using, what if I was using our formula and the angles are double? Let me say you made something like this. 6a plus, let me say this is 4 times maybe 3 sine of 6a. As long as these angles are the same. So here, where you come to say your r is maybe r sine, here the angle, for you put that angle 6a plus maybe alpha. That's the only thing you change. For you put the angle the way it is here. Even if it was 7a, for you put 7a here times that angle, and then you expand. Hope that one is clear. I'm looking through the chart. Senyonja has replied, what if it was sine 3a? Still, you can use the R formula or you can use that. But now for that one of sine 3a, then you have to expand it in that format. But if the angle is here, let me say at 2a, then there the best formula to use is R. Now you need to know when you are where can I use this? In case this was 2a and this was 2a, the best formula I can recommend is using R. If these angles are not single angles, the best approach to use is R, unless when you know how to express them as a single angle. That's when you can go on and use your T formula. So now allow me now that we start now working out. So now here we have said we have 3 cos of A plus 4 sine of A equals to 5. So we are going to substitute what we had for our cos. Our cos, we said we had 1 minus t squared out of 1 plus t squared plus our 4 into 2t out of 1 plus t squared is equal to 5. So what are you going to do? You notice that this 1 plus t squared is the LCEP, so I'm going to multiply it throughout. So you can do your manual way. You multiply here by 1 plus t squared, multiply here by 1 plus t squared, multiply this side by 1 plus t squared. So you notice this and this cancel, this and this cancel. So that means that at this point, we shall remain with 3 into 1 minus t squared plus 4 into 2t is equal to 5 into 1 plus t squared. So when you open up, you'll have 3 minus 3t squared plus 4 times 2, which is 8t, is equal to 5 plus 5t squared. So you collect like terms. So I can take the 3 this side, the 8 this side, everything this side. It is very, very okay. So when I take the 3 this side, this is negative. Once it crosses, it becomes a positive. So I have 8t squared plus, okay, I take the 8 the other side, it becomes negative 8. I take the 3 the other side, it becomes a 2 equals to 0. So meaning that I'll have 8t squared minus 8t plus 2 equals to 0. Now when it comes here, it is okay. Use any approach you want. Either you can use the formula, you can use completing squares, you can use. But one thing I want you to do is that when you are using bulldozer, avoid using x all the time. In case you are writing it is in terms of t, define it in terms of t. That this is negative b plus minus b squared minus 4sc out of 2a. And then you tell us that my a is 8, my b is negative 8, and my c is equal to t. So don't go on and instead use what? X, because now you are solving for t. So we shall come here and substitute and say our b is negative 8 plus minus our b here, which is going to be negative 8 squared plus 4 times 8 times 2 out of our 2 times a, which is 8. So this will give us 8 plus minus. When you check inside, you'll notice that that is 0 out of 16. So meaning you'll have 18 out of 16, and our t will equal to a half. Now remember, you have not completed, so you go back and say that your t was equal to tan of a out of 2. So that means that where there is t, you put the value you have got. So here we shall have our half equaling to tan of a out of 2. So what are we going to do? We want to obtain this angle. So we shall say a out of 2 will equal to tan inverse of a half. So you place your calc. What is tan inverse of a half? Is 26.57. But remember here, it is not only that angle, because now I don't want you to cram. Next time you'll find that the first angle is here, which is 26.57. Where is the second angle? Remember here, all and tan is positive here. So this angle is also 26.57. So another angle you could have could be 180 plus 26.57, which is 206.57. And the angles you have obtained are equal to a out of 2. But you want a So meaning that now your A is going to be, you multiply by 2, multiply by 2. So it will be 2 times 26.57. 26.57 times 2, wait, 26.57 times 2, which is going to give us A is equal to 53.14 degrees. When you multiply this, the other 206.57 times 2, you get 413 point this. So now at this point is where now you go back and look at your item, what your item wanted. So when you go back, you notice that our item wanted us to check whether the angle we are obtaining is between 50 and 55. So when you look at the answer we have obtained our answer as 53.14. And you notice that that angle is between that. So now you are going to make your conclusion and say that since 50 degrees less than maybe 53.14 degrees less than 55, something like that, the engineers should go on and approve the proposed spotlighting setting. Or you can say the engineers should go on and approve the proposed spotting setting. Why? Because 53.14 lies between 50 and 55 degrees. So that is how you make a conclusion on that. So that's when you use your T. So I want you to be well conversant with both approaches because it depends what you are working out. Sometimes you may find that using that T makes the life very easy. Using the R also can make the life very, very easy. So you choose which approach to use. But you need to be very careful when you are going to use your R and when you are going to use your T. Okay. Jakisa, I have not yet received your question. Yes. And I want to avoid writing angles to 1 decimal point. Unless you have got it like that. If it's not, please write to all decimal places. Yes, Maria?
Good morning, sir.
Morning.
Mr. For me, I have not got it. When do we use our formula and when to use T formula? Is it just an alternative?
Yes, it is an alternative. But like I've said, if you find that you have sine A plus cos of A, let me say here there is anything, maybe any number. Whenever these two angles are the same, you can either use T or you can use R. But if it is a single angle, the best approach to use is either T or R. But if you find that the angles in between here, they are the same, but let me say you have 3A and 3A. Now, for such angles that are beyond one angle, the best to use is R. Understood?
Yes, teacher. Yes, I've got it.
Yes, sir.
Okay. Yes, go on. Ask.
Good morning, sir. My
Yes,
question
morning.
is that when you're given, for example, the question is saying that a plane contains a line and they give you the vector equation of that line and also passes through a certain point over point N and they give you the coordinates and you ask to find or to get the equation of the plane. How do you get it?
They have given you a plane and they have
uh,
given you a point.
the plane contains a line and again that same plane passes through a certain point. For example, A that is 1, 2, 3. How do you find the equation of the plane?
Okay, so they have given you the vector equation of a line.
Yes.
And they have given you a point.
Yes.
And now they want you to find
the equation of the plane.
Okay. Now, you need also to ask yourself that if I have a line and a point, can I form a plane? You know plane?
Yes.
Yes, you ask yourself, if I have a line and I have a point, can I form a plane?
You can.
You can. How does it look like?
When you have a line and a plane. Line and a plane. Yeah, you can. You have a line and a point. Can you form a plane?
Now, what you need to understand is that if you have just a line and you have a point, let me say you have a point, you may not be able to form a plane.
You can't.
Now, there are conditions for you to form a plane. Hope you are listening. The
Yes.
condition for you to form a plane, they must give you something more. Beyond that, that maybe if they have given you can I say they need to give you some more information, much as you can form it. Now, what you do for that case, if they have not specified, you can find the normal vector. That is the first thing. Because what you need to know, have you done parallel? Have you done something called the parallel vectors?
Vectors, yes.
Yeah. So if it is in that form, then you have to first find your normal. After finding the normal, then you can use that. So what you do, you go to that line, extract that line they have given you, maybe you extract the vector. You extract their, in case they have mentioned something like parallel, then it can come out very well. But if they have not mentioned, then it may be a bit tricky for you. But always, the easiest way to form is when you have 3 points. A plane can be formed when you have 3 points, when you have maybe 2 lines, but a point and a line, it may be hard for you to find it.
So what if they say that the line is perpendicular to the plane?
The line is it?
Perpendicular to the plane.
Yes, and what are you finding?
Like they want you to find the equation of the plane, yeah? But they say that the line, it is perpendicular to the plane, and for that one there, it's a different scenario whereby they give you a what, a plane, and they give you the normal, is it the normal vector of that parallel of that perpendicular line?
And they want you to find what
Equation of the plane.
the equation, like they have given you, let me say, they have given you a line. Let me say this is my line, and they have given you something perpendicular to it.
Yes,
Something like
they've
that.
only given you the directional vector of that line.
They have given you the direction vector. Then that one is very, very possible. You can find the equation of the plane.
Okay, so we take that directional vector as the normal.
As the normal.
Okay.
And then you are going to just dot. Let me say this is the point they have given you, which is point A, and maybe this is point B. So what you do, you dot your A, dot B, then you dot it with the direction equal to 0. And then you can form it.
Okay.
Yeah. But if they don't mention perpendicular, then it becomes very tough for you to know. So now that one, you need to be very, very careful that one of the possible ways is when they have given you the perpendicular vector. If they have given you that it is perpendicular and they have given you a point and the vector equation of a line, it is very easy for you to go on and find your equation of the plane. You just dot. You get this point they have given you. Let me say they have given you any point and dot it with this C direction vector they have given you. Okay. So we are going to continue. Sorry. Let's first complete this item. When we go back to this item, allow me now to move it further. When we go back to this item, they went on and told us that, okay, I think this is the item. They have gone on. When you look at the third part of the item, they have gone on to tell us that now the company is also supporting the development of a new city. At the center of the city, a circular recreation park is constructed such that its boundary is represented by the equation. For safety and accessibility, the planners have set a minimum distance of 5 kilometers between the center of the park and a city reference point. the proposed park will be approved only if the condition is met. Now, what are you going to do? You need now to first find out what is the center for that. After that, you find out the distance between the two. So now here, I'm going to first write my equation, and I will say my circular park is x squared plus y squared minus 8 plus 6y minus 11 is equal to 0. So that is what I can first find. Now, after doing so, I know some of you the best approach is using completing squares. But if you find yourself having issues with it, then you can go on. You can go on and use the other approach of just what? Equating. It's okay if at all you don't know. But though I would advise that better you learn everything such that in case of anything, you are not limited. So in case we're using completing squares, I'm going to first pair my x squared minus 8x plus y squared plus 6y minus 11 equals to 0. So we say that your b always you square it. You divide it by 2. So we shall have x minus 4 everything squared minus negative 4 squared plus our y plus 3 when you divide 6 by 2 minus our 3 squared minus 11 equals to 0. So this will be x minus 4 squared plus our y plus 3 squared minus 16 minus 9 minus 11 equals to 0. So this is x minus 4 squared plus our y plus 3, everything squared. Then this is minus 36 equals to 0. So meaning that this is x minus 4 squared plus y plus 3 squared equaling to 36. So what does it mean? It means that in a standard equation, it's going to be y plus 3 squared equaling to 6 squared. So meaning that our center here is going to be 4 and negative 3. Your center, you pick it from here, 4 and negative 3. And your radius is going to be 60 kilometers. That's what you can do for such a case. So what else can you do? I know some of you may want to compare. Let me say some of you want to go on to your standard equations, 2fy plus c is equal to 0. And then you want to compare the two equations that my 2gx, what is it equaling to? It is equal to negative 8x. Then you say that 2g, is it negative 8? I think, is it negative 8? Yes, that is going to equal to negative 8. And then you say your g is equal to negative 4. Then you want to compare your 2fy. You compare it to 6y. Then you say 2f is equal to 6. Your f is equal to 3. Then you go back and say now, what is my center? That the center is given by negative g and negative f. That one is also okay. It is also okay as long as you have shown how you are obtaining the other parts. So here you'll come and you tell us that now my center is going to be negative g, negative f. So this is going to be negative 4, negative 3, which is still 4 and negative 3. As long as you know the standard equation. So you can work it that way in case you want. Then from there, remember the question told us, when you go back, the question told that for safety and accessibility, the planners have set a minimum distance of 5 kilometers between the center of the park and the city reference point 00. So in other words, you are finding the distance between the center and 00. So I'm going to come and say that now. I don't know whether I have space. Obtaining the distance D from the center park, our center park was for -3 to the what? To the reference point, which is 0, 0. So that means you have 2 points for -3 and you have 0 and 0. So we shall say now our distance will equal to x2 minus x1 squared, then plus y2 minus y1 squared. So here you substitute, this is 4 minus 0 squared, then plus -3 minus 0 squared. So here you're going to end up with 4 squared plus -3 squared, which will give us now 16 plus 9, which gives us 25, which is going to give us 5 kilometers. So you note that from here, they told you that from our scenario, they told us that the minimum distance of 5 kilometers. So you notice that the answer you have got is 5. When we talk about minimum means what? That is the least you can have. So since we have got the least distance, then it means that our condition is being satisfied. So minimum means the shortest distance, the shortest gap. So that is what we can have. So we shall now conclude that the required minimum distance is 5. Therefore, the condition is being satisfied. So what should the engineers, was it engineers? You stick to the character being used in the scenario. So now here is between, remember, the planners have set a minimum for safety and accessibility. So that means that you will tell us that now, therefore, the road will be easy to access and it is very safe. And therefore, they can go on and the proposed park can be approved. Okay, so that is how you attempt that part. Okay. Okay, using the formula for radius, someone got 14. Kindly check out. There is a problem. Your radius should be 6. Your radius should be 6. Yeah, the way we got it there. In case you can go on, because this is what? G squared plus F squared minus C. So when you square those things, you will not be able to get that. Okay. Okay, so we are going to what? To continue. I think the person who's getting 11, the mistake is here. Please, you pay attention. This is 4 squared plus 3 squared minus your C is here. From here, your C is -11. So make sure you bring -11 here. So that is going to be, this is going to be 16 plus 9 plus what? 11. So you cannot get your answers that. So hope you have seen where the mistake is. So this is 36, which is going to give you 6 as well. Okay. So that is how you can conclude. Then the last bit of the item, they went on and told us that the track has an equation. This is the equation. The engineers will approve the design of the racing track only if its eccentricity is less than 0.85. Now here we have gone into geometry 2. When it comes to geometry 2, now you need to be very careful. What is this? Now when you look at that, it means that now you need to remember your knowledge that here we look at parabolas and ellipse. So the equation that has been given to you is an equation of an ellipse. Remember, an ellipse, this is the kind of equation that we always have when it comes to an ellipse. So that is the equation of the ellipse. Now, what do you need to know? What has the question given us? That the question has given us x squared out of 9 plus y squared out of 25, and this one is equal to 1. Now, I want you please to take note that we have basically two types of ellipse. We have what we call an horizontal ellipse. Horizontal ellipse, how does it look like? Your horizontal ellipse will look like this, something like this. That is the horizontal ellipse. And when it comes to the horizontal ellipse, what do you always look out for? You look at the value of A and the value of B. Whenever the value of A is bigger than B, then that is an horizontal ellipse. In other words, if you find that this value of A is bigger than B, then it means that it's going to be an horizontal ellipse. Then when it comes to the vertical ellipse, something like vertical ellipse, because next time they may tell you to sketch it a bit. In case it's a vertical ellipse, for it will be like this. And what do you base on? You look at A and you look at B. Whenever the value of B is greater than A, then it's going to be this value of B is greater than A, then it's going to be our vertical ellipse. Now, if I may ask in the chat, what kind of ellipse do you think we are going to get? Is it horizontal, vertical? It's going to be a vertical ellipse. Very good. So now it means that your y is bigger. Hope my screen is on. Okay, so what are we going to do? Now, we are going to find the equation of the eccentricity. So here, I'm going to write that we have x squared, s squared, plus y squared out of b squared is equal to 1. Now, I've said that whenever a is greater than b, here you'll get. Then in case I have x squared out of, let me say this is b squared, plus y squared out of s squared is equal to 1, then here it means that whenever your a is greater than b. So this one is always what we call the vertical, and this one we call it the horizontal. Now, how do I get my eccentricity? So we shall use this formula that b squared is equal to a squared into 1 minus a squared. Now you compare this equation with this equation here. I want you to please take note. Always first identify, is it vertical or horizontal? This is like a generic what? A generic formula. So what are you going to do? You are going to come here and say that your a squared is equal to 25. And what is your a now? A is going to be square root of 25, and your a is equal to 5. What is your b? B squared is the 9. So what are you going to get? B is going to be root of 9, and b is going to equal to 3. So what are you looking for? You are looking for e. So you substitute your 5 and you substitute your 3 in here. So your b is going to be 3. Here is going to be the 3 squared. What is going to be your a squared is going to be 5 squared into 1 minus a squared. Someone may ask, why are we even just, you could even just substitute them. There is no problem. So here, sorry. Okay, let me create some space. Let me create some space. So what are you going to have? So we are going to have here our 9 equals to 25 into 1 minus e squared. So you divide through by 25, 9 out of 25 equals to 1 minus e squared. So you want e squared, so I can just interchange. I have e squared equals to 1 minus 9 out of 25. So you shall have e squared equals to, this is 0.64. So you get the root, So your eccentricity is going to be 0.8. So that is how you obtain your eccentricity for that particular ellipse. So what next? Now after obtaining that, you go back to your original equation and then you compare with the value you have. You go on and compare with the value. So when you go back to the scenario, you notice that in the scenario, they told us to check whether the eccentricity is less than 0.85. And when you look at the answer we have obtained, it is less than. So you say that since 0.8 is less than 0.85, the track meets the requirement, and therefore the planners should approve both the proposed park and the racing track designs. Next time, they are going to just give you an equation. Please, you need to understand. Next time, they can just give you an equation. They can give it to you in this form. 9x squared plus 6y squared is equal to 25. And they ask you to find the eccentricity of this. So please and please, take note that still, even if they have given it to you in this form, first transform it into a standard form. The standard form means that you are going to go on and divide. So you can first divide through by what? Let me say by 9. So you say, I have x squared plus 16 out of 9, y squared is equal to 25 out of 9. Then you continue dividing. Now I need to remove the 16. So you say x squared out of the 16 plus, now this one becomes y squared out of 9 is equal to 25 out of 9. And here also there is what? There is 16. So you need now to do it in that particular format. So please and please make sure that before you do anything, you always first transform it into that particular form. Then from here, you need to know that now for here, it's going to be, since the x is bigger, it's going to be an horizontal eccentricity. Now for such a case, still you do b squared is a squared into 1 minus e squared. So remember that your b is always the bigger thing. B stands for, when it comes to your b is going to be like that. Your b is going to be that particular part that takes on the other. So please take note whenever you meet such things. I think this is, I don't know that I've divided very well, but here, even here, I think, let me even make it better. I think I've not divided well around here, but you have to divide very well, and then you get the right thing. So in fact, the best way even I would advise is for you to come, you get 9, you get 16 and 25. I think also this one can work. So you keep on dividing. But remember, before you let this, the whole of this side must equal to 1. That is the standard one. So please take note, because I've told you that the standard one should be, this is what? Y squared out of b squared is equal to 1. So never calculate, never let BA when this side is not equal to 1. So meaning that also you have to first make this side 1. That's why I think this is the best approach to use. 9, 16, 25, then you find what goes throughout. So here, after doing whatever thing we are doing, make sure that you let equal to 1. So here in simple terms, it can be x squared out of, let me say 25 out of 9, then plus this can be y squared if you divide by that 25 out of 16, and then is equal to 1. So please take note of that. Never make your calculations when this side is not equal to 1. That one then is not a good ellipse. So please take note. Next time you'll find when you have something like, let me say 3x squared, maybe plus 6y squared, then plus maybe 12. Now here, I think, let me first take you through this quickly, because they can give you the equation in any format. So you need to be well conversant. So always what you do, let me say, let me go back to this one here. In case you want to get it in a simpler format, what you do, you remove the 25 first. So I can divide by 25, divide by 25, divide by 25. So you get 9 out of 25x squared plus 16y squared out of 25 is equal to 1. Now, how do you remove this 16? You know from your mathematics, if I have 2x, I can write this as x divided by 1 out of 2. Because x divided by 1 of 2 is the same as x divided by 1 out of 2, which is x times 2 out of 1, which goes back to 2x. Now, this 16 here and the 9, I can write it in that form. So I can write x squared out of 25 out of 9. Plus, I can write y squared out of 25 out of 16 is equal to 1. So that's how you can approach. In case, let me say you had 3x squared plus 6y squared is equal to 12. Still, first divide by 12. For you, divide by 12 by 12. So you get x squared out of that is 4 plus y squared out of this is 2 is equal to 1. Now, if it is in this form, then this is very good because it's already 1 and your x and y already have a coefficient of 1. So now that one is very okay for you to continue. In case maybe you have found something 9x squared plus 4y squared is equal to 36. Still do the same. First divide by 36. Divide by 36. In case something can reduce, then go on and reduce that. Maybe this is x squared. This is what? 4 plus y squared out of 12. Is it 12? No. By 4, 1 by 4. This is 9. Is it 9? No. Is it 9? No. That is what? Yes. 36 divided by 4 is 9. And then equals to 1. So you can reduce it in that particular format. So that's how you can. Yes. Now, I think I've seen the concern. Let me draw for you. Now, when it comes to an ellipse, we have what we call a major axis and what we call a minor axis. The major axis and then what we call the minor axis. Like I've told you that the standard equation is this. That is the standard equation. And we have basically two types of ellipse. You have the horizontal and you have the vertical. What determines the other? What determines the other is going to be A or B. So when you come for horizontal, when this A is bigger than B, when A is greater than B, what are you going to have? You are going to have something like this. You are going to have that. It's going to be an horizontal ellipse. Now, for such a case, in case you are finding its eccentricity, then it is very okay to use the formula. B squared is equal to A squared, 1 minus A squared. However, in case it comes to the vertical one, I'm going to change. I'm going to have x squared out of b squared plus y squared out of a squared is equal to 1. If I'm to use the general formula, this general formula for eccentricity, so here when I come, this is going to be my vertical. Is going to come. That's why I let my A to be 5, and that's why I think B was 3, something like that. So that's why we interchanged. We interchanged because you need to know that your B, this value of the B is going to be that value that is, when you look at the two, the value that is smaller, then A is the value that is bigger. So B is the smaller value, A is the bigger value. So that's why here I interchanged, such that this formula remains relevant. Otherwise, if you do not change those two values, you'll get a wrong answer. Okay. Hope it is now clear. Let me know through the chat whether now it is clear on eccentricity. Okay. Okay, it is clear now. Okay. So allow me now to give you some numbers. You are going to try out. I don't know whether we did this. No, did we do this? Oh, I think we did this. Yeah, I think this is the number we did. I don't know which mock board it was, but that's how you had to do it. Yesterday, I posted for you this one. We did a number similar to this when it came to Wakata. The number was similar to this. So you take a screenshot, you try out on your own the same approach, the way we approached the other one. So you can take a screenshot. Okay, hope you have taken a screenshot. Then this was Matigo. Also, you take a screenshot here. The only thing I want to emphasize, there is someone who asked, what if the angles are different? And I want to use this case of Matigo as my case study. From everything you are going to do here, we did something similar to this yesterday. I want to just bring out this issue here, that they have told him that from the medical camp, a helicopter is to pick up these casualties and transfer them to a specialized hospital for medical attention. The helicopter landing is modeled by this. Now, whenever you find that this angle is down, this is single, then you need to think about the trigonometric identities. So that one is very, very key. So now for such a case, it was cos of 2 theta plus cos, let me be sure, was it 2 theta? Okay, yes, cos of theta. Now for such a case, what you do, you first write this. You must first express these ones to be in the same angle. So there you can use your trigonometry, that cos of 2 theta is what? Is the same as cos of theta plus theta, which is the same as cos theta minus sine of theta sine of theta. So this gives you cos squared theta minus sine squared theta. Since this single angle is already in cos, express everything in terms of cos. So this means this is cos squared theta minus 1 minus cos squared theta. Because sine squared theta is the same as 1 minus cos squared theta. So here you get cos squared theta minus 1 plus cos squared theta. So here you end up with 2 cos squared theta minus 1. So that is what you are going to place here. So you set 2 cos squared theta minus 1 plus cos of theta equals to 0. So you form your good equation as 2 cos squared theta plus cos theta minus 1 is equal to 0. And then from here, you solve. You can use your bulldozer. Some people have letting that saying let cos theta equals to maybe y, and then you get your 2y squared plus y minus 1 is equal to 0, and then you do the solving. After getting your y, you go back and let what your cos is. For this case, allow me to just put the answer that in case it is this case, here your y is going to be a half, and then the other y is going to be negative 1. Then after that, don't forget to bring it back here and say that cos theta is equal to a half. Then you find the angles. That cos theta is equal to negative 1 and find the angles, and then you go back to conditions. Okay, let me take on a few questions. Samsung, Melissa, Tayewa, you may ask.
Good morning, sir.
Yes, morning.
Yesterday when you posted this, yesterday when you posted this Matigo number item 1. I tried it out, but then I had a problem. What's the difference between crossing T1, T2 with T1, T3 and crossing T1, T3 with T1, T2?
Crossing, like when you are finding the normal vector. Oh, Melissa, what were you finding?
I was finding the normal.
Now, the normal, let me say you have come up with some, this is maybe your plane. I'm just using this. And you have placed for us T1 here, place T2 and T3. Now, like I told you, to get the normal vector, Melissa, always have one reference point. Either you can use T1, T2, or T3. Which one did you use?
I used T1 as
T1.
my
Now, if you start with T1, you'll cross T1 and T2. Then you'll cross, pay attention to the direction, you'll cross T1 and T3. That's how you can get your normal.
Now, what is the difference with me crossing T1, T3, then T1, T2?
It is the same.
I was getting different answers.
Crossing T1 and what? If you cross, now remember you are going to have, did you first obtain T1 and T2?
Yes.
T1 and T2. Hope you went on and said this is going to be 1 minus 7, 3 minus 3, and then 9 minus 6. You got that?
Yes.
And then after you got your T3 minus T1 in vectors. Then after that, you went on and crossed, and you said this is I, this is JK, then you cross the two vectors.
Yes, but when I cross T1, T3 first.
When you cross?
When I start with T1, T3. I get negative 21, I 24J, 42K. But when I cross T1, T2 first, I get a positive 21, negative 24, and 43, which makes the answers different.
Okay, you have crossed which one? You have crossed T1, T2, and then you have crossed them with T1 and T3. This is what you did.
Yes.
And your answer was 21I minus 24J plus 42K.
Yes.
But when?
But when I start with T1, T3, then T1, T2, I get negative 21, positive 24, and then positive 42.
Those are the same things. But if this is what you crossed, if this is what you crossed, Melissa, this is the answer you are supposed to get. This is the if you cross T1, T2, T1, T3, this is the answer.
Okay, thank you.
And hope you got for your plane here. Your plane will be 21x minus 24y plus 42z is equal to 327. 327.
Yes.
Okay, and your distance was 9.61. Okay. Kali, that is
Good
okay.
morning.
Okay.
Good
Yes,
morning,
morning. Morning.
Mister, the other number that we are working on, the one we use the T formula.
Yes.
I tried out using the R formula, and I found out that using the R formula we get a 53.13 degrees. So when you use the T formula, you got a 53.14. So when they are marking that difference, is it considered or?
Now, where the difference came from, it came from you. You rounded off early. You had premature approximation.
Okay.
You look at the angle you use. Did you write to 3 decimal places or you wrote to 1 or 2?
2.
Now that's where the problem comes in. Whenever you premature approximate something, your levels of accuracy keep on reducing.
Okay, mister. Thank you.
Okay.
Yes,
Yes.
my question was on coordinate 2. I wanted you to explain for me. There is like a locus, but there's also a four key. Is it called a 4 key?
You are saying you wanted?
I wanted you to explain for me what a 4 key is in coordinate
Now,
2.
have you done coordinate geometry 2? Have you started it or you have not done anything about it?
Yeah, I've started it.
You have started it, eh?
Yeah.
Okay. Then that one can be okay if you have started. Now, under coordinate geometry 2, a few things that I want you to take note of. Number 1, I want you to know how to deal with a parabola. And you need to know that when it comes to the parabola, we have what we call, conic section. We have what we call the focus. Focus is always that fixed point. Is called the focus. Then the fixed line is what we call the directrix. Then the ratio is what we call the eccentricity. So when you are talking about a focus meaning you look at that point that is focused. The point that is fixed is what we call the focus.
Oh, okay.
That fixed point that you base on. Let me say, have you ever rotated on your, let me say you stand here on your foot and then maybe you rotate like this.
Yeah.
Now, this point that is fixed is what we call the focus. So it's just a fixed point. So you rotate and then you form your locus. So when you rotate like your leg and you move like this point here is what we call the focus. Now, this path that your foot traces out is what we call the locus. So the locus can be a semicircle, can be a circle, can be any figure. As long as the distance from that fixed point to any point along that path that you have described is the same.
Oh, okay. Thank you, sir.
Okay. I think Weko, you are the last. Weko?
Good morning, sir.
Yes, morning.
Sir, now I was wondering how you got under the ellipse there. Ellipse, how you got that in. I don't know how that in came in and the X and Y disappeared.
X and Y? No, have you done, because now it depends. Have you done coordinate geometry too?
Not yet.
Not yet, because that is a standard formula. It is a standard formula. So I've just picked it. It is a standard formula.
Okay, thank you, sir.
Okay. I think we are going to end here our session. We shall meet tomorrow again. So tomorrow, we are going to be alternating the papers. We shall be looking at paper 1, paper 2, paper 1 and paper 2. But on Thursday and Friday, because I have a program, we shall start at 4:30. We shall start at 4:30 because at exactly 6:30 I must be somewhere. Okay. So let me wish you a good day. Try out those numbers. Now, white sugar. What if it was cos 2x plus cos x is equal to 3? Yes, you use the same approach. Okay. Okay. So you try out those. I will send more items for you to try out. for number 1. Otherwise, have a good day. Bye-bye.